Hi guys, welcome to my YouTube channel. My name is Mr. Zest from Zest Academy. Right, so what are we doing today? Today we are doing definitions and laws of exponents. We are doing definitions and laws of exponents. Right, so I'm gonna take you through definitions and laws of exponents from law number 1. Right, so what is law number 1? Law number 1 says if any base is raised to the power of 0, if any base is raised to the power of 0, it is equal to 1. Don't forget that your base cannot be equal to 0, so that's a restriction. And then law number 2, if any base is raised to the negative exponent, it is equal to the reciprocal of the same base raised to the same positive exponent. If any base is raised to the negative exponent, it is equal to the reciprocal of the same base raised to the same positive exponent. Again, the base cannot be equal to 0. Law number 3, when multiplying same bases, you keep the base. You keep the base and you add the powers, or you add the exponent. When multiplying same bases, you keep the base and you add the exponent or powers. Law number 4, when dividing same bases or like bases, you keep the base and you subtract the powers. You keep the base and you subtract the powers. Like one mistake that students always make is to take this the exponent or the power of the denominator and write it first, and then subtract the power of the numerator from that of the denominator. That's wrong. You must always subtract the exponent of the denominator from that of the numerator. Right. Then law number 5, when we have something like this, when we have a base raised to a power like that, and then you have a bracket, and then we have a power outside, what do? You keep the base and you multiply the exponent. You keep the base and multiply the exponent. So if you get something like this, all you have to do is to keep the base and multiply the exponent. Law number 6, right? Law number 6, you can see that if you have a fraction, you see that when a fraction is raised to an exponent, all you have to do is to distribute. You have to distribute your exponent to the numerator and to the denominator. Remember, here you have an exponent of 1, so it will be 1 times m, and then that's m, and then it will be 1 times m as well, and then it will be m as well. Right, so I hope that is clear. And then law number 7, if your power is a fraction, as you can see, right, what we do, it means that the base will be raised to the numerator. And rooted to the denominator. Right, so we're going to do some right. Law number 6, when a fraction is raised to an exponent, the numerator and the denominator must be raised to that exponent. Right, as you can see that we have a fraction here raised to an exponent. Both the numerator and the denominator must be raised to the same exponent. Right, as you can see here. Law number 7, if the exponent is a fraction, the base is raised to the numerator. As you can see, the base is raised to the numerator, and it must be rooted to the denominator, as you can see. Right? Law number 8, when says are multiplied, they can be split apart and rooted individually. When this says, so let's get like, let's say this is like 12. Actually, I'm going to give you more example. Let's say this is 12. 12 can be written as 4 times 3, right? All that rooted to n, as you can see. So it means we can write that as root of square root of 4 times square root of 3. So that's what they mean here. When sets are multiplied, they can be split apart and rooted individual. So you can see that we splitted x and y and we rooted them individually. Right. Law number 9, or very last law, law number 9. When taking the root of a root, it is actually the same as taking the single root of the product of both roots. Right. So look at this. Here we have the root of m, and we also have the root of n. So what they're saying here, it is actually the same. Taking the root of x, you can see that here x is rooted to both m and n, so it is actually the same as the product. You multiply this to m times n, so you have mn, all that. So that's what they're trying to say here. When taking the root of a root, it is the same as taking the single root of the product of both roots. So that's what they mean here. Great, thank you. So in my next video, I'm going to do some examples. I'm going to show you how to simplify exponents using all these rules, and I'm also going to show you how to approach problems and apply your definitions and laws of exponents. Thank you. Watch the next video for more.